teachers and students. Today we're going to be talking about the states of matter, solids, liquids, and gases. And I'm going to use these marshmallows and toothpicks to illustrate how molecules in solids, liquids, and gases are arranged. In a solid, like an ice cube, the molecules are arranged with a structure called a lattice. That's what the toothpicks here represent. We've learned from previous experiments that molecules are always moving. They're always vibrating. And the hotter they get, the faster they vibrate. So an ice cube that's very cold would have molecules moving very slowly. But as it warmed up, a couple of things would happen. The molecules would move faster and that ice would melt. Now, if I were to shake this little model I've made, the lattice would break apart. Those toothpicks would come undone from the marshmallows. And then they would be detached from each other. And that's what happens during melting. So here's a cup of water molecules, and they are free to move about on their own. They are no longer stuck to each other. So that's what a liquid looks like. Liquids take the shape of whatever you put them in. So I put them in this beaker, they're in the shape of a beaker. But if I dump them in this tray, they're in the shape of a tray. So solids hold their shapes, but liquids change their shape according to gravity. Well, what about when it turns from a liquid to a gas? That's causing it to move even faster and faster. And those molecules of water will go from a liquid to a gas. They will evaporate. And then they're moving like crazy. So if I shook these a whole bunch, they would not only stay in my hands, they might do this. And that's what a gas does. The molecules just go everywhere. They're not related or connected to each other in any way. So we're going to do some experiments now with ice, solid water, liquid water, and gaseous water, and some other solids, liquids, and gases. For our first experiment, we're going to be mixing a solid and a liquid to make a gas. And you may have worked with this solid and liquid before. We're going to mix baking soda and vinegar. Do you know what's going to happen when we mix those two chemicals? Have you tried that before? So baking soda is a solid. It has a shape to it. Now this baking soda has been crumbled into a powder, and I put it into this balloon. The vinegar, of course, is a liquid, and I put it in this graduated cylinder here. Now vinegar is an acid. It's a pretty mild acid. It won't burn your skin. But if you got it in your eye or a cut or some part of sensitive skin, you'd sting a little bit. So it's a mild acid. Baking soda is the opposite. It's called a base, and they don't get along. So what I'm going to do is attach this balloon to the top of my graduated cylinder and then tip it so they mix. So I'll be mixing this solid with that liquid. Let's watch what happens. So there I go. There's my liquid. Here's my solid. Look what happens when I mix the two. Look at the balloon and what it's doing. Something is blowing up that balloon. It's also getting pretty cold too. The temperature is changing. And what's happened is I've mixed a solid and a liquid, and it's forming a gas in that balloon. Now most gases are invisible. You can't see them. So if I just done this without the balloon, you wouldn't have seen much happen. It would have bubbled up, but you can't actually see the gas that's forming in there. But that's what's happened here is I've mixed this solid and this liquid and made a gas that inflates that balloon. I wonder what kind of gas that is. Do you think that's the same air that we breathe? We'll do another experiment and find out. For our second experiment, I'm going to mix the same solid and liquid in a large container. And we already know that it's making a gas of some kind. And that gas will be inside this jar, but just like the air in this room, you won't be able to see the gas. So let me take some baking soda and put it in here. And some vinegar, and you'll watch it foam up. Those bubbles are producing the gas. And right now, as those bubbles pop, that gas is filling this container. But we can't see that. It looks just like our air. But is it air? Well, watch closely. Let me let all the bubbles pop, and here we go. Oh my goodness. What just happened? Let's try that again. How does it do that? Well, it turns out that the gas that's formed in here is heavier than the air I'm breathing. So it stays in here, just like if I filled it with water, the water would stay inside that container. Just like water takes the shape of a container, so does gas. And just like you can pour a liquid, you can pour a gas. So this is full of a gas in here that fire doesn't like. And it's still in there, and when I turn it like this, some of it pours into there and extinguishes that fire. Now, do you know what kind of gas this is? It's carbon dioxide. It's the same gas that is produced in a fire extinguisher. And fire does not like carbon dioxide. When we breathe in the oxygen that's in our air, but what we breathe out is carbon dioxide. Plants like that, fire does not. So there I took a solid and a liquid, and I made a gas that's called carbon dioxide. So we're here in the school kitchen now, and I'm going to fill some cans with some water. Now I could put in solid water, which is ice, then I'm going to heat it on the stove. And as I heat it, it will turn from a solid to a liquid, or I could just pour liquid into here and it would do the same thing. But as I heat it more, those molecules will move faster and faster as they get hot, and it will turn into water vapor. It will evaporate. And when it does that, something interesting will happen. Right now, this can is full of the air that I'm breathing. But when I evaporate the water, it will fill full of water vapor, and it will push the air out of the can. Now, one of the interesting things about vapors or gases compared to liquids is they're a lot bigger. They spread out quite a bit as those molecules evaporate. In fact, water grows over 1,000 times its size. So if I put 1 cup of water in here, the water vapor, the gas, would be 1,000 cups big or more. So as it evaporates, it's going to fill this up with water vapor and push the air out. There will be no more air in here. There will simply be gas water. Then I'm going to cap it and cool it down. And it will turn from a vapor back to a liquid. And it will shrink when it does that, because liquids take up less space than gases. What do you think will happen to these cans when I do that? I won't need much water in that can, because as I say, once it evaporates, it will expand a lot. So I have the burner on and the water is starting to heat up. Once it gets really hot, I'm going to seal the cans. This one I'll seal by putting on this lid. These I will seal by turning them upside down and immersing them into that bath of ice water. When I do that, it's going to cool the water vapor inside and cause it to shrink from a gas down to a liquid. What do you think will happen to the cans when we do it? You can see the steam escaping from that can as the water is heating up and turning from a liquid to a gas. As it's doing that, it's pushing the air out of the can and replacing it with water vapor. We'll let it boil a little bit longer. Now these cans are no longer full of air, they're full of water vapor. It has turned from liquid to a gas. Watch what happens when I cool the gas off and turn it back into a liquid. Immediately it shrinks, causing that to occur. Let's try another one. Now this solid steel can is sealed. It's very warm to the touch from that hot vapor inside. Now you can crush an aluminum can with your hand, but could you crush this steel can? Well, watch what happens when I cool the vapor down to a liquid. It is already starting to collapse the can. As that water vapor cools down and turns back into a liquid, it does the opposite of expansion. It contracts. And this contraction will bend that can. Can you see the steam coming out? What's happening now is this, and it's invisible so you can't see it, but this is what it's doing in there. the water was liquid. When I turn the water to gas, it takes up a lot of space, and it pushes all the air out of the can. Then I sealed the can so air can't get back in. Now it's going to cool off. When the gas cools, you know what it turns into? A liquid again. And if I cooled it even more, it would freeze to an ice cube, wouldn't it? If I put it in the refrigerator or the freezer, it would cool off. So as that goes from a gas back to a liquid, it takes up less space. So the gas takes up lots of space. There it goes. Do you see what it just did?
You made a dent.
As it goes back to liquid, it's turning back to a small space, and it's going to crush the can. It's going to crush it even more.
It's because the can that was...
So look at the sides of the can. It's not done. It's going to crush it even more.